Okay, grade 11s. We're starting with geometry. Okay, so grade 11's geometry is much nicer than grade 10's. Grade 10's was on the quadrilaterals. Okay, so we're also going to know or learn and use the quadrilaterals, but the grade 11 geometry is called circle geometry. So it's all about properties of a circle and angles that are created because they are inside of a circle. Okay, so the first thing we need to know is the terminology of a circle. It was also on the investigation yesterday. So the first thing we're going to go through is this. So a perpendicular line from the center to the chord. Okay, we're going to see what happens when we see that. The bisector from center of the circle, we're going to see what happens there. Angle at the center equal to 2 times angle at the circumference. We're going to look at that one. Angle in a semicircle, angles in the same circle segment, opposite angles of a cyclic quad, exterior angle of a cyclic quad, tangents from the same point, tangent, and you can just put it in there because the printer doesn't print that sign. It's tangent, it's an upside down T, perpendicular to the radius, and then tangent chord, tan chord. Those are going to be all of the theorems that we are going to look at. So the first thing I need you to look at is a circle. You all understand what a circle is. We have a radius. A radius is a straight line from the center of the circle to the circumference of the circle in any direction. All radii in the same circle are equal in length. In other words, if you look at this circle, there's a radii, there's a radii, there's a radii, and they all have the same length. Okay. A straight line from the one side of the circle to the other through the center is called a diameter. Okay, so it has to go through the center to be a diameter. Perimeter, that's the distance around the circle. A chord, very important. This is a word that we're going to use a lot. A chord is a line from the circumference of the circle to the other side, but that doesn't go through the center. Okay. So actually the diameter is also a chord, but it's a specialized chord. It's got an extra something to it, an extra property. When the chord goes through the center, it's called a diameter. But the rest is just called a chord. So like that line from there to there, that's a chord. Does that make sense to you? That's not a chord, that's a radius, because it's not from circumference to circumference. Right. Arc, part of the outside of the circle. So when we look at the arc, it's when that chord, you see that chord there? That's a straight line, then it's a chord. But from the one side to the other side of the circle on the circumference, but it doesn't have a line. That's called the arc. So it's the same distance if you were to go directly, but if a line is drawn, it's called a chord. If there's no line there, like that part there, that's a arc. Okay, so it's when it's a distance from between 2 points, but on the circumference, not through the circle. A segment is a portion of the circle formed when a chord cuts a circle. That's a segment. And then the last one, a tangent, very important, a straight line that intersects the circle at just one point. So if you have a circle and there's a straight line that cuts the circle, that line can only cut the circle at one place. Now obviously when we draw, you can look even there on the sketch, when we draw this on a computer or even with our hands, it seems like it's touching for like a centimeter. Do you see? But in actual fact, it only touches that circumference for 1 point, and then it's done. Okay. All right. So we are going to divide the theorems into 3 main categories. The first one is going to be the midpoint theorems. So if you have a circle, but there's no midpoint, a center, there's no center given, you can't use those theorems. For example, you know the parallel line functions, the theorems, the fun functions. If you don't have parallel lines, you can't use them. If you don't have a center, you can't use the midpoint theorems because you need the midpoint in order to use them. Okay, we're going to look at them now. The next one is the cyclic quadrilateral theories. Now, do you know what a cyclic quadrilateral is? Do you know what a quadrilateral is? Yes. It's a shape that has 4 sides and 4 angles. But it doesn't have to be like a square or whatever. The lines don't have to be equal to each other, the sides. It's just 4 sides and 4 angles. So when it's a cyclic quadrilateral, it's a quadrilateral that fits into a circle. Okay? So all the 4 vertices will be on the circumference. For example, let me just show you a quick example here. If I have a circle there, and I make 4 points anywhere, and I join them, they don't even have to be joined, then that is a cyclic quad. But if this line goes from there to there, goes from there to there, and there, that's not a cyclic quad, because that point doesn't touch the circumference. You got it? Yes. Got it. So we've got 3 theories at the midpoint, we've got 3 theories at the cyclic quad. If there's not a cyclic quad, you cannot use the cyclic quad theorems. It's as easy as that. So you don't go looking for the outside angle of a cyclic quad if there isn't a cyclic quad. You don't go and look for a triangle's theory, the sum of the interior angles of a triangle if there's not a triangle. Do you understand? Okay. And then the last 3 is called the tangent theories. Right, there we also have 3. Now tangent, I told you, is when there's a straight line on the outside of the circle that only touches the circle once. Whenever we're going to have a question about, in an exam, and it looks like there's a tangent, but they don't tell you that it's a tangent. So if you look at APB, if it's not given APB is a tangent, then you can't assume it's a tangent. Okay. Very important about geometry. If you can't prove it, and if it's not given, it's not true. Okay? You cannot assume things. You cannot say, oh, but it looked like a 90-degree angle, and that's why I took it as a 90-degree angle. You can't say, but it looked like it was a tangent, that's why I used it as a tangent. If it's not given, and you can't prove it, then it's not true. You can't use it. Okay, we remember that. Okay, so we're going to start at the first 3 theorems. It's the midpoint theorems. Okay. Now, I'm going to just quickly show you the theorem from the textbook. You don't have to, you're not going to learn them right now by heart. Eventually, you're going to have to know them by heart. But now we are just going to look at them so that you understand that what we are saying is absolutely true. Okay. So when you look at this diagram, they will tell you that there's a circle, there's a line from the center to the chord. Do you see that's a chord? And this chord is being bisected, being cut in half. Now what we want to prove, and what Theorem 1 says, is if you've got this situation, there's a line from the center onto the chord, and the chord is being bisected, is being cut in half. Then we know that M1 and M2 will be 90 degrees. Okay, that's what Theorem 1 says. It's also got a converse. The converse says if you've got the same situation and M1 or M2 is 90 degrees, then we know that the other one is also 90. If you have that situation, we can know that AM is equal to MB. Do you understand that? Okay, now if we were to prove it, we'd have that circle there with the line from the center onto the chord being bisected. We would construct, listen to me, we only construct when we prove a theorem. Okay, so like this, when we want to prove what we are saying here is true. So I would construct a line there and there. So I have created two triangles. Do you see it? Now what we're going to do is we're going to prove congruency. So I've got AM equal to MB, it's given. Okay? OM is a common side in both of them. So OM is equal to OM. There's my second congruency. OA. Do you know what OA is? What's it? Radius. Do you see it's a radius? From the center to the circumference. And what's OB? And what did our, right there at the beginning, our terminology say? Radius is equal in the same circle anywhere. Okay, so that means that OA and OB are also equal to each other because they're both radii. So I've got side, side, side equal to side, side, side. So do you agree those two triangles are congruent to each other? Congruent means they are exactly the same in size. And because that is a straight line, and that angle will then be equal, né? We can know a straight line is 180, divide by 2, that angle is 90, that one is 90. So if the line from the center onto the chord bisects the chord, then the angles will be 90. If this line did not bisect the chord, so the length from here to here is not the same as the length from there to there, can you even see that those angles can now not be 90 degrees? It's even obvious visually. Although we don't go on anything visually, but you understand what I mean. Okay, so that is theorem 1. And then the opposite. So whenever it's given, the angle is 90 degrees, then you can know that the chord is being bisected. If it's given that the chord is being bisected, you know the angles are 90 degrees. Do you know anything about a triangle that has a 90 degree that you've got some prior knowledge about? What do you say? What? Yeah, but where do we use a right angle triangle? Pythagoras. Okay. So this one will most of the time go along with Pythagoras. Okay, because you've got a 90 degree angle. So they'll either give you the 90 degree angle, you can use Pythagoras already, or they're gonna give you the equal sides, then you can prove the 90 degree angle and you can do Pythagoras. Okay, that's theorem number 1. Theorem number 2 looks like this. Only look at this one triangle. So we'll have something that kind of looks like a triangle, but it's not a triangle, it's actually a quadrilateral. Not a cyclic quadrilateral, because that point's not on the circumference, it's just a quadrilateral. So what's actually happening is I have the 2 points AB, it's an arc. There, you see that arc. That arc forms an angle at the center. And that arc also forms an angle at the circumference. The correct word is that AB subtends. Subtends. You'll get used to that word, subtends. It means that angle is born out of those 2 points. Okay? AB subtends an angle at the center, and AB subtends an angle at the circumference. So theorem 2 tells us what the relationship is between the angle at that circumference and the angle at the center, when both of those angles subtend from AB, from the same arc. Okay, so in the theorem, we would construct a line from that angle at the circumference through the center to the other side of the circumference. So we're actually making a diameter. Right. In this triangle, we would have that C1 and this is an important property, and A1 or A is equal to each other. Do you know why? Because these two lines are radii, and therefore it's an isosceles triangle. Okay? And do you see that angle right there, N1? Do you see N1? N1 is an exterior angle of this triangle. So that would mean that N1 is going to be 2 of those dots, because the exterior angle is equal to the sum of the opposite interior angles. Happy with that? Okay. In the other triangle, C2, you see they aren't the same size, no? But C2 and B will be the same size. Do you know why? Why? The radii has created an isosceles triangle. So they are equal to each other. And do you see N2? O2. There. It's an exterior angle of that triangle. And the exterior angle is equal to 2 times the opposite interior angle. So this one is 2x. So this whole angle is 2 dots and 2 x's. And that angle there is 1 dot and 1 x. So can you see the angle at the center is double the size of the angle at the circumference? And that's the property, or the property of the second theorem. The angle at the circumference is equal to half of the angle at the midpoint. Or the angle at the midpoint is 2 times the angle at the circumference. Theorem 2. Theorem 3 is just an extension from Theorem 2. Look at this one. Do you see once again we've got AB? The arc there. Do you see it's once again subtending an angle at the circumference? And do you realize that it's subtending an angle at the midpoint as well? Do you know what the size of this angle is? What? 180. So if we know theorem number 2, that says the angle at the center is equal to 2 times the angle at the circumference, what do you think the size of that angle will be? 90. So theorem 3 is just an extension of theorem 2. It says when the angle is subtended by a diameter, that angle will be 90. Do you understand why? Who says no? Did you say yes, all of you? So if it's the diameter, because that angle is 90, 180, that one will be 90. And then theorem 3 we call angle in a semicircle. Do you know what a semicircle is? Half of a circle. Do you see there? It's half of a circle. So if the angle is in the half of a circle, that angle is 90 degrees. Okay, we're going to start with the 3 of them. You can open or page to the next page at Theorem 1.1. It says there, if a line from the center of the circle intersects a chord at an angle of 90 degrees, the line will divide the chord into 2 equal parts. And then the other one, it's the same one, it's just the converse. If a line from the center of a circle bisects the chord, then that line is perpendicular 90 degrees to the chord. So if it's given that it's 90 degrees, you know that it's being bisected. If it's given that it's being bisected, you know that the angles are 90 degrees. That's theorem 1. Okay, how do we use this statement? Example 1. Solve for x. You see x there? Do you see it? Look at what information is given in the question and the sketch. Finding the size of an angle without giving the correct reason is worthless. 0. Okay. So firstly we know that PR, no, that's not equal to 6. Yeah. PR, yeah, it was given PR is equal to 6. So it means from here to here it's 6. OQ is 4. O is the center. They don't tell you it's the center, you can't assume. O is the center. And it's given that Q is 90 degrees. If I look at this problem, it seems like I'm working with a Pythagorean triangle. Do you agree with that? When you were in grade 8, I told you you need 2 things to do Pythagoras. The first one is a 90-degree angle, and the second thing is 2 known sides. I have a 90-degree angle. I have one known side. The other side I have is this whole thing, PR. That's 6. I don't know what PQ is. And do you see, I only want to work with PQ. That's the side of the triangle. So I am stuck. I have a bit of a problem. But do you agree with me? I know Theorem 1. And Theorem 1 says if the line from the center is perpendicular to the chord, then that line is bisecting the chord. Prior to 15 minutes ago, did you have the knowledge that that line is bisecting that chord? No, you didn't have that. Before, 15 minutes before now. Did you know that? No. So that is the knowledge that you have to write down. That is what you cannot. I remember when you're writing a geometry paper, you must assume I know nothing. That's the only thing you can assume. I know nothing. So you are going to start solving this problem by saying PQ is equal to QR. Did they give you that? Did they tell you that in the information? No, that's your knowledge. So when you use your knowledge, you have to give a reason. Why do you say PQ is equal to QR? Then this is now your reason. Line from center perpendicular to chord. That's where you get your mark. That's where you've used the theorem. That's where you've used grade 11. Does that make sense? Now, because I know they are equal to each other, I can say, thus, PQ is equal to 3. Just remember we said PR is equal to 6. They gave me that. It was information given. Can I do Pythagoras now? Because I've got a 90-degree angle and 2 known sides. So I know that PO, which is x, is equal to 3 squared plus 4 squared. My reason is Pythagoras. And therefore x is equal to 5. Is it hard? No, it's not hard, no? Okay. Can we move on to example 2? You have to calculate the length of OB. It's that one right there. Look at this sketch with me. I've got that side, it's 17. I've got AC, it's 16, and they're telling me it's being bisected, so I know that side is 8, and I know that side is 8. It feels like I want to do Pythagoras. Do you agree with me? But with the information I have, can I do Pythagoras? Why not? I don't have a 90-degree angle. But am in grade 11. And I know that when there's a line from the center and it bisects the chord, then that angle is 90 degrees. So you cannot do Pythagoras before you have proven the 90-degree angle, right? Remember, that's what, remember in grade 8 I said, we need two things to do Pythagoras, and all of the questions had those two things in. It was never a problem in grade 8, but that's why I said it to you back then. Because we know, I need to get that in your head. Two things. If there's not a 90-degree angle, I need a 90-degree angle. If there's not two known sides, I need to get two known sides before I can even start. So I'm going to say, OB is perpendicular to AC. It was not given. Perpendicular means 90 degrees, né? But why can I say this? My reason is line from center bisects the chord. Thus I can say angle ABO is 90 degrees. Now I can do Pythagoras. Ne? So I say OB squared is equal to 17 squared minus 8 squared. So I'm doing Pythagoras in a shortcut. Do you see that? You're not getting marks for the steps like in grade 8 and 9. You get marks for giving your reason Pythagoras and showing that you're going to do Pythagoras, and then you get a mark for your answer. And I think that is 15. Let me just check. Yes. OB is 15. So when we started this period, I showed you the proof of the theorem, why we can say what we're saying. Now we are doing the application. We are only going to do the application in the exams. You don't have to do the proof. When we're going to have our classes later on, we will do the theorems. Okay. Can we look at the example for Theorem 2? Do you remember what Theorem 2 is? The angle at the center is equal to 2 times the angle at the circumference. And those two angles must be, what's that word? Subtended by the same chord or arc, the same 2 points. The same mom and dad must have a baby at the circumference, and the same mom and dad must have a baby at the center. Then they will be double. You remember? Go. Theorem 2. When lines from 2 points on the circumference subtend, create an angle at the center of the circle, and the same lines from the same points also subtends an angle on the circumference of the circle, the angle at the center will be twice the size of the angle at the circumference. Look how easy this is. What is the size of x, grade 11s? X is equal to 110 degrees, and my reason is angle at center equal to 2 times angle at circumference. That's doable, ne? Okay, I'm going to give you just On page 216. Nee, on page 216. 16. I want you to do A, B, D, and then for a challenge you do E and I. It's exercise 2. Alright, listen to me. You for tomorrow, né? You don't have to go and redraw these sketches for this homework. Because you will see, look here at A and B, it's just like this example now. They give you the center angle is 60. Remember, the one in the middle is the one that's bigger. Né? So you're just going to give X is this, for what reason? X is that, for what reason? And then you can somehow get a hint there for C. Look, AB subtends X and AB subtends C. It's a reflex angle. Okay, and then I, you see there's a triangle and radii.